Hi guys, today we are doing lesson 1.2.2, which is about parallel and perpendicular lines, as well as something called direct variation. So as always, go ahead, pause the video, try the warm up on your own, then you can unpause it and look at my solutions. So on number 1, this is going to be different depending on which student is answering this question, because you guys all will probably have a different memory of parallel and perpendicular lines. You may remember parallel lines look something like this and they never intersect. And you also may remember that perpendicular lines look something like this and they intersect at a 90-degree angle. So we'll learn all about that, refresh our memories on those today. All right, number 2, this is from your guys' last lesson. We had similar problems to this. So we're going to write the equation of the line in point-slope form that passes through these 2 points. So point-slope form, quick refresher on that, is y minus y1 equals m times x minus x1, where the x's and the y's are just from each point, okay? So I'm going to label my points x comma y. It really doesn't matter which one's x1, y1, or x2, y2. I'm just going to label those because it is very easy to get confused with the x's and the y's. So the first thing that we're going to solve for is the slope. So remember, m, or the slope, is the change in the y divided by the change in the x coordinates. So if we look at the change in the y coordinates, it does not matter which y we start with, as long as you start with that for both x and y. So I'm just going to start with this point. I'm going to put a star by it so I remember which point I start with. So I take that y value 3 and I subtract this y value, which is a negative 8. Please make sure you put that in parentheses because a lot of students will forget that extra minus sign. So you're subtracting a negative. Okay, then I started with this point, so I go back to that for x. So negative 5 minus 2. And then I simplify. So minus negative becomes a positive, and then we have 11 divided by negative 5 minus 2 is negative 7. So the slope here is negative 11 sevenths. Okay, so then I'm going to plug this in for the slope, and I am also then going to plug in an additional point. Now, you could choose either point to write this equation with, so I'm going to show you both equations that you could potentially get here. So if you use the first point right here, you would get y minus the y value, which is 3, equals m, so the slope, times x minus this, minus negative 5. And that minus a negative is going to then become a positive. So I'm just going to rewrite that. So x plus 5. Okay, so that's one answer that you could have gotten. Or if you used the other equation, or sorry, not the other equation, the other point, you'd get y minus a negative 8. So minus a negative 8 would then become a positive 8. So I'm just going to save myself from rewriting it. Equals negative 11 sevenths times x minus the x value, which is 2. So either one of these equations is acceptable. All right, so parallel lines. Like I just said in the warm-up, parallel lines are ones that never intersect, so they look something like this. This is the definition over here, written over here, that your book has. So it just says 2 lines with these 2 slopes are parallel if and only if their slopes are equal. So that's the main thing that you need to write down about parallel lines, is they have the same slope and they never intersect. So the reason that they never intersect is because since they have the same slope, the lines are growing at the same rate of change, or at the same pace. So if they're growing at the same rate of change, then one line is never going to have the chance to overtake the other line and surpass it or cross over it. Okay, so they have to have equal slopes. So let's find a parallel equation. So this says find the equation of the line through this point, 1, 3, and parallel to this equation. Just a side note, the symbol that we use for parallel in math looks like this. So anytime you are feeling lazy like I sometimes am and you don't want to write out the word parallel, just go ahead and draw that little image. Okay, so first things first, we have to know what the slope of the original line is because we know that we have to find a parallel slope or the same slope in order to get this new equation. So given this current format, which is standard form, I don't know what the slope is. So I am going to first solve or rewrite in slope-intercept form because that's going to be the quickest and easiest way to see what the slope of this original line is. So remember, slope-intercept form is y equals m times x plus b, where m is the slope. So if I can get it in this format, then I can figure out what the slope is. So in order to do this, in essence, what I have to do is I just have to get y by itself. I have to isolate y. So first things first, I would have to move the 3x to the other side. So I would subtract that. Now, instead of writing negative 24 minus 3x, I'm going to put the negative 3x in front. And that is because I know that I want the m times x term in front. So negative 3x minus 24. Then I have to divide both sides by 4. And instead of writing this whole thing divided by 4, I'm going to divide each individual term by 4. Because again, I want to know what is this slope and what's this y-intercept. So this becomes y equals negative 3/4 x minus 24 divided by 4 is 6. So now I'm able to tell what the slope is of this line, which is a negative 3/4. So I'm going to write that down. So the new line that I'm finding, since it's parallel, it has to have the same slope. So it has to have a slope of negative 3/4. And then let's look back at the original facts. So it also has to go through the point 1, 3. Now, since the directions don't specify, you can write this equation in either slope-intercept form or point-slope form. I would just do point-slope form because that is going to be the simplest and fastest way. So y minus y1, which is 3, equals m, so negative 3/4 times x minus the x coordinate, 1. And then you're done. Now, if it did ask you to find this in slope-intercept form, you can set it up the same way. And then just like we did over here and we got this equation in slope-intercept form, you'd have to do the same. You'd have to distribute that slope and then add the 3 to the other side, get y by itself, and that's how you would go about that. So just pay close attention in your homework because there are some questions that I give you the option. And if I were you, I would just use point slope form and make it faster. But then there are some that I do specify having to get slope intercept form. Okay, so there's the solution. Perpendicular lines. So like we said in the warm-up, perpendicular lines, what makes them special is that they intersect at a right angle or a 90-degree angle. Okay, so that's what this little symbol right here is for, so 90 degrees. This is the formal definition over here of perpendicular lines. It says their slopes have a product of -1. What I'm going to tell you is even more important than that is that their slopes are, or where that comes from in essence, their slopes are opposite reciprocals, which I'll explain in just a second. So opposite meaning opposite sign. And then reciprocal, if you guys remember, that means the fraction has been flipped. So the numerator and denominator flip, which I'll show you that in a second. Okay, and if they're opposite reciprocals, their product will multiply to give you -1. So looking at these examples, let's say this is the slope of one line, this is the slope of the second line. These are all opposite reciprocals. So 1/2, that's positive, so opposite sign would be a negative. And then the reciprocal of 1/2 is 2/1. You flip the fraction, so -2/1. You don't have to write the over 1 though. That's why you can just leave it as a whole number. Okay, 6/5, the opposite sign, since this is a positive, would be a negative. And then flipping 6/5 becomes 5/6. Opposite of 5, we write that as a fraction. That's 5/1. It's positive right now, so it becomes a negative. And then we flip the fraction, so -1/5. And then same thing for the last two examples. The product of the fraction and its reciprocal is always going to be a -1. That should be a negative right there. That's just kind of a side note. You don't really have to remember that off the top of your head. And really that's just because when you multiply it times its reciprocal, so let's say this first example, the reciprocal basically cancels out the original number, and since it's the opposite sign, you're left with a negative symbol. So this would become negative 2 over 2, which becomes negative 1. Okay, same thing with 6/5 times negative 5/6. 6 times negative 5 is negative 30. 5 times 6 is 30. That simplifies to give you negative 1. So really all I need you to remember about perpendicular lines right now is that they have opposite reciprocal slopes. All right, let's go ahead and find a perpendicular line. So now it says find slope-intercept form. Okay, so we are specifying of the line perpendicular to negative y equals negative 2/3 x plus 2. Also, side note, symbol for perpendicular that we can use for shorthand looks like this. Okay, so it's like a little upside down T just showing they're intersecting, and then you can put that 90-degree little box right there. All right, so first thing we have to identify is what's the slope. So the slope of the original line is negative 2/3. So then the new slope of the perpendicular line would be the opposite reciprocal. So this is negative, so the opposite's going to be positive. And then we flip the 2/3, so it becomes a positive 3/2. So that's going to be our slope. And we know that it has to pass through the point negative 2, 1. So once you have your slope and your point, you are good to write the equation in point-slope form, and then we're going to convert it to slope-intercept form. So we have y minus y1, which is 1, equals the slope times x minus x1. So minus a negative 2, I'm just going to rewrite that as plus 2 right now. And then in slope-intercept form, which again is y equals mx plus b, that means I'm going to have to distribute this 3/2 inside the parentheses to get rid of the parentheses, and then I'm going to have to move the minus 1 to the other side. So first let's distribute this. So this becomes 3/2 times x plus 3/2 times 2. I'm just going to write that out first. So 3/2 times 2, I'm going to write that 2 as 2 over 1, because anytime you're multiplying fractions, it's easier to have them both as fractions. So then I get y minus 1 equals 3/2 x. Plus 3 times 2 is 6. 2 times 1 is 3. Okay, then I'm just going to rewrite this up here. Y minus 1 equals 3/2 x plus 6 divided by 3 is going to simplify to 2, which makes our lives a lot easier. And then the last step is I have to add this 1 to both sides to get y isolated. So y equals 3/2 x plus 3. So this is in slope-intercept form, and it has a perpendicular slope. Perfect. So this is that problem, and this just shows you the line's graph. So this is a slope of up 3 over 2, and then this is its perpendicular line, so down 2 over 3. Opposite reciprocal slope. Okay, rates of change of a linear function. Just to remind you guys, any linear function has a constant rate of change. So that just means the rate is not changing or fluctuating at all. So for every unit that you increase in x, the same amount of units in y, a consistent amount of units in y, is going to have to increase. Okay, so it's not going to increase by one amount and then change and increase by another amount, which you guys probably already know or remember. So this is an example here. This just shows that for each unit that is increased in x, y here is increased by 60 units. So each unit increased by 1 in x, y increases by 60. Okay, so it's consistent every single time. 60 is being added, so every hour that goes by, you are driving an additional 60 miles. That would be an example of a linear relationship because the rate of change is the exact same. It's constant. If it changes, it's not linear. So the last thing we're going to cover today is direct variation. Direct variation is a special type of linear relationship or a special type of a line. Okay, if you notice, this is a line that goes through the point 0, 0. So it has a y-intercept of 0, which you would normally write like y equals mx plus b. If b is 0, you'd write it as y equals just mx plus 0, which is just the same thing as y equals m times x, whatever the slope is times x, okay? So this is where we get this equation from for direct variation. So this is the equation for direct variation, which I want you to write down. Anytime we have a case or an instance of direct variation, we say that the variable y varies directly as x does. So it varies directly, or another terminology that you'll see is it is proportional to x. Okay, and what this is right here, this k value is just in place of m. Okay, because we want to call it something a little bit different since it's a slightly different type of line. It's a special type of line. So k is just the constant of variation. So that is how much it is changing. That's the ratio. In essence, it's like the slope. It's the growth. Okay, so this is just a slightly different way of writing it. We have y equals k times x instead of m times x. The other thing that you guys need to know, the other formula that you need to memorize for this is that k, the constant, or the rate of change, is equal to y divided by x. This is very similar, again, to slope. Slope is change in y over change in x. So it's basically the same thing. We're just calling this k instead of m. Okay, so direct variation means as x increases, y increases directly with it. There is a direct correlation. So one variable is directly affecting the other variable, and it's starting at 0. There's nothing else that's affecting that, okay? So some examples would be like, the more that I drive, the more miles I go. The more people I'm cooking for, the more ingredients that I have to buy. So as one thing increases, the other also increases at the exact same rate. Okay, so it's just a special type of line. Again, very, very similar to y equals mx plus b. It's just now, instead of the m, we have the k, and the y-intercept is 0. So let's do some algebraic examples. This is the type of problem you're going to see on your homework. So again, this is that language we're looking for. If it says y is proportional to x, that just means it's changing at that same rate every time. So y is proportional to x. Use the x and y values given below to find a linear model that relates them to each other. So we know that we want to get the equation y equals k times x. And we also know that k is y divided by x. Change in y divided by change in x, okay? So all that we have to do is find this equation right here. So we've got x equals 3 and y equals 7. So first let's find k, the constant. So k is y divided by x, so 7/3. And then we plug that into our equation. So y equals this value, the k value, 7/3 times x. And it's as simple as that, okay? Then the next one, we've got k equals, again, y divided by x. This time we can simplify this. 3,480 divided by 10 is 348. And then when we write this as the equation, we get y equals this constant, 348, times x. And that's all, okay? So again, direct variation just means y is being directly affected by x. So it's some multiple of it, okay? Again, think about the example of like, if I have 2 times the amount of people that are coming to my house to eat dinner, I need 2 times the amount of ingredients. So it varies directly. It causes that direct change. Okay, direct variation in their graphs. I already talked about this a little bit. This is a version of y equals mx plus b. M equals k in essence, okay? It's the constant, or it's the slope, or it's the rate of change. And the only difference here is that now b is equal to 0. and the graph will always, always, always go through 0, 0 for direct variation. So these are the key things that you have to write down. It's always going to go through 0, 0, but m is the same thing as k. It's just that we're writing it with a different variable so that we know it's a little bit unique, and the b value or the y-intercept is 0. So if you're looking at these example graphs, tell which of the following would be an example of direct variation. Well, we have to look for the one that, first of all, is a line, and then secondly, that goes through 0, 0. So those are the only ones that are going to be examples of direct variation. So it has to be a line that goes through the origin. This one does not. This one does. This one is a line, but it does not go through 0, 0. And this one goes through 0, 0, but it's not a line. So just this one right here is an example of direct variation. Okay, and then this is the exact same page. I'm not sure why there's a second one of that. All right, so we made it through the lesson, guys. Sorry that took us a little while. Here is your homework, page 25, numbers 57 through 67, and page 36, numbers 5 through 10, and page 37, numbers 19 through 22. So all of these are going to be found on the 1.2 book problems. Remember, you are never doing the warm-up problems, so you're just going to start on these first problems where you're looking at the exercises, okay? And you can look at the page number in the upper left corner.